Today we're going to be talking about scatter plots. When we look at them, we're going to describe the patterns that we see, such as clustering, if there are any outliers, whether it has a positive or a negative association, if it looks like a line, or if it doesn't look like a line. Before we actually look at any scatter plots, we need to talk about some vocabulary. What actually is a scatter plot? A scatter plot is a graph where there's different points plotted, and they're all scattered all around. We're going to talk about things like correlation. Basically that means, does it look like there's a relationship between the two axes? So as one goes up, does the other go up? As one goes up, does the other one go down? Or is it all spread out? Trying just kind of looking at which way the dots move. So again, are they moving upwards in an upward trend? Or are they moving in a downwards trend? Strong is when they almost make a straight line, and weak is when they're scattered all over the place. Finally, outliers are points that don't really seem to fit with the rest of the points. Like they don't really fit the pattern. First, let's look at some scatter plots that have positive correlation. As you can see, the x-axis is on the bottom, the y is up and down. As the x increases, so as you go from left to right, these dots get higher and higher and higher on the y-axis. This is how you know it's positive. As you go from left to right, it goes up. This one on the left has a stronger correlation. They make more of a straight line, while the one on the right, they're a little more spread out. But all three of these have positive correlations. One example of something that would give you a positive correlation, as you can see, is the time you spent studying and your grades. So the more time you spend studying, the better your grades will be. In negative correlation, as the number on the x-axis increases, the number on the y-axis decreases. So as you're moving from left to right, the points go downwards. Again, the one on the left has a very strong correlation. This looks like it's almost a perfect line. The one in the middle is a little more scattered, so maybe that's a weaker one. Some examples of things that would give you negative correlation is the amount of time you spent training and the time it takes you to run 100 meters. So the more time you spend training, the less time it's going to take you to run that far. If a scatter plot doesn't have a positive or negative correlation, and it looks more like the points are scattered all over the graph, we say it has no correlation. What this means is that really the two things have nothing to do with each other. So it doesn't matter, as x increases, you don't know what's going to happen with y. It could either increase or decrease. An example of things that don't have any correlation are shoe size and IQ. Just because you have big feet doesn't necessarily mean you're a smarter person. Okay, let's read some examples and decide if they give us a positive, a negative, or no correlation. So our first example, height and weight. As your height increases, what happens with your weight? Typically your weight will increase also. So since height goes up and weight goes up at the same time, we call this a positive correlation. Number 2, the state you live in and your shoe size. Shoe size can go up. Do you have bigger feet if you live in a certain state? Or do you have smaller feet because you live in a certain state? Not really, so these two we'd say have no correlation. Number 3, hours spent playing video games and school grades. Okay, so the more hours you spend playing video games, so as this one goes up, what's going to happen with your grades? Typically, if you're playing video games all night, you're not spending your time studying or doing homework, so your school grades would go down. So this one would have a negative correlation. Now let's make a scatter plot given some ordered pairs. So my x values are on the top, and my y values are on the bottom. So my first point I'm going to put at 1, 2. So 1, 2, put a point. Next point is at 3, 3, 3 over, 3 up. Next point, 4, 4, 4, 4. Next point is at 5, 3, 5, 3. And last point is at 6, 5, 6, 5. Okay, as we can see with all our points on there, it's not a perfect line, but it does seem to have a strong correlation because they are very close together. And since these points tend to go upwards, this has a positive correlation. Let's try one more. Okay, we have 6, 3, 3, 5, 4, 1, 1, 3, and 2, 2. Now these points are scattered all around. It almost looks like a circle. So this scatter plot would have no correlation. Thank you for watching. Now go out and make some scatter plots of your own.